The main idea of the approach that we have followed for designing a recursive method for this problem is that we splitted the array into a sub-array of size n-1 whenever we call the method recursively. Now the question is this is the only split we could have if we want to find the maximum element of an array? The answer, of course, is not. So let us explore another split if we want to find the maximum element of an array. Now here we are going to explain the other recursive design for finding the maximum element of the array. The idea is that to split the array into two halves, then find the maximum recursively for each half. In the previous design, we splitted the array into a sub-array of size n-1, and we called the method recursively on this sub-array. So now for our array here, we are going to split it into two halves. And we are going to have two calls. We are going to call the method recursively on the first half, and we are going to have another call recursively on the other half. And the return values from these both calls will be compared and the maximum will be selected. Since we are going to call the method recursively on the two halves, then we need to keep a track of the beginning and ending of each half whenever we call the method. Therefore, we need two integer variables. One is used to indicate the start index of the array. The other one is used to indicate the end index of the array. So whenever we say start, we mean the start index, and whenever we say end, we mean the end index. So how to split this array into two halves? In other words, how to find the middle index when we split this array into two halves? For our example, the value of a start for this array is equal to 0, and the value of the end index is equal to 4. To split the array and find the middle index into two halves, we use the following equation. We subtract the start from end, so 4 minus 0 is 4. We divide the answer by 2, so 4 divided by 2 is 2. Then we added with the start, so 2 plus 0 is 2, so the middle index is equal to 2. So therefore, we are going to split this array into two halves. The first half will begin from start until mid, so it will go from 0 to 2. And the second half will start from mid plus 1 until end, so it will start from 3 up to 4. Notice that the size of the array is not even. So when we split the array into two halves, we are not going to have even number of elements in both sides. So one of the halves will have one element extra than the other half. However, if the size of the array is even, then we are going to have two halves with equal number of elements. So visually, we know that the first half will start from 0 up to mid, which is 2, and for the other half, it will start from mid plus 1, which is 2, up to end, which is 4. So we can say that the range for the first half is from start to mid, and the range for the second half is from mid plus 1 up to end. So when we call the method on this half, then we have to give the value for the start is the same value as the start of the parent array, and for the end, we have to give it the value for mid. And when we call the method recursively on the other half, then for the start of the array, we have to give it mid plus 1, and for the end of the array, we give it the end of the parent array. So based on our initial discussion, the method should have three input parameters. The first parameter is the array, the second parameter is the start index of this array, and the third parameter is the end index of this array. So whenever we call the method on the first half, then we have to provide the array as well as the start and end of this array. And whenever we call the method on the second half of the array, again we need to provide the array with the start and end indices of this array. And when the return values of the both calls are returned, they are compared and the maximum value is selected as the maximum value. Notice that the array is splitted into two halves. One is on the left and one is on the right. So this is why we are writing left branch, which is the first half, and it is drawn on the left hand side, And the second half is called right branch, and it is drawn on the right hand side. Now we have two halves, then we need to apply the idea of splitting each half into another two halves. So let us start with the left branch. The value of start is equal to 0 and the value of end is equal to 2. To find the middle index, you subtract 0 from 2, so 2 minus 0 is 2, divided by 2 is 1, plus 0 is equal to 1. So the middle index is equal to 1, so therefore we need to split this half at index equal to 1. So the first half will be from 0 to 1, so from start to mid, and the second half will be from mid plus 1 to end, and mid is equal to 1, plus 1 is 2, and end is 2. So this half will start from 2 and will end to 2 at the same time. Now since the start is equal to end, so we are going to have an array of one element. So therefore, this is the only element in the array, so we assume that this is the maximum. So to call of this method on this array will retain the only element in this array, which is equal to 1. And this will be considered as the base case or the stopping condition for calling the method itself recursively. After splitting the first half, then we need to go and split the second half. The value of start of the second half is equal to 3 and the value of end is equal to 4. So the middle index is equal to 4 minus 3, which is equal to 1, and 1 divided by 2. I know the answer is 0.5, but here we are dividing integer over integer, so the answer will be equal to 0. And 0 plus 3 is equal to 3, so the middle index is equal to 3. So therefore, this half will be splitted into two halves. The first half will start from 3 to 3, because the value of start is 3 and the value of mid is equal to 3. And the second half will start from 4 to 4, because the value of mid plus 1 is equal to 4 and the value of end is equal to 4. And again, for the two halves, we are reaching the stopping condition, so the return value for the call of this method with this array will be 16, and the return value of this call for this array will be equal to 9. And these two return values will be compared and the maximum value will be selected. Now on the left branch, still we have an array that needs to be splitted, and this is the half that needs to be splitted into two halves. The value of start is equal to 0 and the value of end is equal to 1. So we are going to find the middle index as 1 minus 0 is 1, divided by 2 is equal to 0, because we are dividing integer over integer, and 0 plus start, which is 0, the answer is 0. So the middle index is equal to 0. So therefore, this half will be splitted into two halves. The range of the first half will be from 0 to 0, which is from start to mid, and the range of the second half will be from 1 to 1, which is from mid plus 1 up to end. And like what we have done in the previous half, the return value when we call the method with this array will be 8, and the return value when we call the method with this array will be equal to 6. And both of these return value will be compared and the maximum will be selected. Since we don't have any array that needs splitting, that means the recursive call has stopped and all calls have reached the base case or the stopping condition. So let us start with the left-hand side branch. For the last two calls of the left branch, the first call will retain 8 as the maximum value, and the second call will retain 6 as the maximum values. And when these two values are returned, then at this level, the maximum is selected, which is equal to 8, will be as the return value. And on the right-hand side, we have reached the base case, and the return value for this call will be simply equal to 1. And when 1 and 8 are received at this level, the maximum value will be selected, which is equal to 8. So we are backtracking. For each return for the two branches, we make the selection. First, we are going to receive 8 and 6. We compare 8 and 6 and the maximum is 8. And then at this level, we are going to receive 8 and 1. And we are going to compare 8 and 1 and the maximum is 8. And now for the right branch, the last two calls, the first call will return 16 as the maximum, and the second call will return 9 as the maximum. And the maximum between 16 and 9 is equal to 16, So we are retaining from these two calls the value of 16. Now at the first level, after backtracking and reaching the first call, 8 will be received as the maximum of the left branch and 16 will be received as the maximum of the right branch. And after comparing these two return values, the maximum is equal to 16 and therefore this call will retain 16 as the maximum. So this is how it works if we want to find the maximum element of an array when we divide the array into two halves. After understanding the splitting criteria of the main task into smaller subtasks, and also after identifying the base case, now is the time to implement the recursive body of the method. Remember that we have to implement this by using branching. And also remember that the method has three input parameters. The first parameter is the array, the second parameter is the value of the start index, and the third parameter is the value of the end index. So in the branching of the if statement, we start with the base case. And the base case is that whenever start is equal to end, so we have an array of a single element, so we retain this single element as the maximum value. Otherwise, we need to make two calls of this method. The first call will be on the left-hand side array or the first half, and the second call will be on the right-hand side array, which is the second half. And we have to provide the range for both halves. The range for the first half will be from start to mid, and the range for the second half will be from mid plus 1 up to end. And whenever we receive these two values, we save them into separate variables. Then we make the comparison and select the maximum. So let us implement this in Java. Here is the implementation of the recursive method in Java. The name of the method is recursive maximum 2. It returns integer as the maximum element in the array, and it has three input parameters: the array, the start index, and end index of this array. First, we test for the base case. If start is equal to end, so we are talking about an array of a single element, so we retain the value of this single element as the maximum, and this single element is at index start or end. So we retain a start, or we can say retain a end. Otherwise, first we need to compute the middle index, and the middle index is equal to end minus start divided by 2 plus start. And remember that all variables here are integer, so the result is supposed to be an integer. Then we have to make two calls of the method. The first call will be on the first half, and the range for this half will be from start to mid. And the second call will be on the second half, and the range of the second half will be from mid plus 1 up to end. And both will retain two values. The first return value will be the maximum for the first half, and the second return value will be the maximum of the second half. At this stage, we have to compare these two values and select the maximum as the return value of this method call. It is clear from the implementation of the code inside the method is that first the method is calling itself on the first half of the array, and then after returning from this call, it calls itself again on the second half of the array. So therefore, the order of calling the method itself is very important whenever we have a recursive design that calls itself more than once. So let us go back to our example and see how each half of the array is visited and in which order. Previously, when we were discussing how the algorithm splits the array into two halves, we splitted the arrays into two halves in random order. First we go to left branch and then we go to right branch, so we were moving randomly. Now since we know the implementation of the algorithm, as you have seen, that the method should call itself first on the first half, then it should call itself on the second half. So therefore we have to follow the left branch all the way until we reach a stopping condition, and then we come back for the right branch for each half. Here for our implementation, I have replaced the equation for computing the middle index by a simpler equation. Although the two equations will give you the same answer, but this is much simpler. So simply you add start with end, and the result you divide it by 2, take the integer part as the answer. When this method is called the first time on this array, it is going to split this array into two halves. Based on the implementation of the method, the method is going to call itself for the first half, and after returning back, it's going to call itself again for the second half. So theoretically, for each call, we are going to have two subcalls. First will be for the first half. After returning back, we are going to have the second subcall for the second half. Since each method has two subcalls for each half of the array, then we need to know in which order each subcall is visiting its half. To do that, we label each subcall by a number indicating its order when it is called recursively. So it is obvious that for each call of the method, first we need to visit the first half. After finishing, then we need to go and visit the second half. So let us call the method recursively on the first half. It is going to split also the array into two halves. And again, we are going to visit the first half before the second half. And for the first half, it is going to split the array also into two halves. And again, we are going to visit the first half before the second half. As you notice that for each calls, the other calls are suspended. So this call is suspended on the second half, and this call is suspended on the second half, and this call is also suspended on the second half. Now, for the call of the first half at this level now, the method is not going to call itself recursively because it has reached the base case or the stopping condition. So therefore, it is going to return this value as the maximum for this call. And now when we return back from the first half, then the method should call itself on the second half. So therefore, the next call will be on this part of the array, which is the second half of the array. And this second half of the array is also a single element. So the method is not going to call itself recursively. However, it is going to return the only element in the array as the maximum. Now at this level, we have two received calls or two return values. Now the method is going to return the maximum of these two numbers, which is equal to 6. At this level, we have called the method recursively on the first half, and on the second half it was postponed. So therefore, we have to call the method again on the second half. And this is why we label this call as number 5. And since this array consists of only one single element, then the method is not going to call itself. It's going to return this only element as the maximum. And finally, at this stage, at this level, when we call this method on the first and second half, now we have returned two values. And the maximum of these two values, 8 and 1, is equal to 8. And finally, for the first call, we have finished calling the methods on the first half. And now we need to continue and call the method on the second half. And on the second half, we have to split the array into two parts. And again, we have to visit the first half before visiting the second half. So therefore, this part of the array is visited first, and since it is an only element in this array, so the method is going to return it as the maximum. And after returning back from visiting the first half, then we need to call the method again recursively on the second half. And on the second half, since we have only one element in this array, so it's going to return it as the maximum. And notice how we are keeping a track of each calls by numbers. First, we label the first half by visiting the first half, and then after returning back, we label the second half with the order of the call. And now at this level, the method has received two values from the previous calls. One is 16 and the other one is 9. Then it's going to pick the maximum, which is equal to 16. And eventually at the end, it's going to call the two return values at this level, 8 and 16, and the maximum is selected, which is equal to 16. So this is how we visit each part of the array according to the order of the recursive calls inside the method. To test the method in JGrasp, first we need to define the method. So the definition for the method will be private static integer, and the name will be recursive max2, and the input parameters will be an array of integer calls a, and the second parameter will be an integer for the start index, and the third parameter will be an integer for the end index. So first we need to test for the base case, for the base case, and here we say if start equal end, then we need to return The only element in this array, either you choose start as an index or you choose end as an index. Otherwise, we need to call the method recursively twice. First, we need to compute the mid index, which is equal to end minus start divided by 2 plus start. And then we have to make two calls. The return value of the first call will be saved into max1, and how to call the method recursively for the first half, we say recursive max2, and we supply a as the array, and for the start it will be the same as start, and for the end it will be up to mid. This is for the first half. Now for the second half, we are going to save the return value from this call into another variable called max2. So we call the method recursively by saying recursive max2, and we supply a as an input parameter, and the range for the second half will be from mid plus 1 up to end. And when we receive or return these two values, then we need to pick the maximum as the return value of the method. So here we say that return, and we are going to use the maximum method inside the math class to select the maximum between max1 and max2. And this ends the implementation of the method, and now we need to test it in our main program. So I'm going to copy this line for finding the maximum in the previous example, and we paste it. So here I'm going to call it maximum2, just to differentiate between the first maximum and the second maximum. And here we are calling recursive maximum2, and we are supplying the array, as well as we need to supply the start and end indices. For the start index, it is 0, but for the last index, it's supposed to be the length minus 1, because the last index in the array is at length minus 1. So here we say length minus 1. So let us run the program. And as you can see, both are given the same answer, that the maximum in this array 3, 5, 9, and 6 is equal to 9.